Welcome friends. Let's continue from our first video where we looked at what is the meaning of dy by dx. So this is where we left. So dy by dx we said is nothing but the change in the y variable for every unit change in x. So we are going to learn how to find dy by dx in this video. In our lecture 2, what we are going to do is we are going to learn how to find f dash of x or the value of dy by dx. So let me repeat, dy by dx is nothing but the change in the y variable for a unit change in the x variable. Okay, so let's start with a table. So in this table, I'm going to show you, let's have two columns. The first column is going to be f of x column. The second column is going to be the f dash of x column. The first thing that we're going to learn is an algebraic function. Algebraic function which is x power n. Now this n denotes a constant. This n is nothing but a constant. What we mean by this is it could be something like x square or x power 5 or x power 426 or any number, x power any number. So x, all of you know, is a variable. More so it's an independent variable. It's a function f of x. This is the f of x function and we are going to find the differential. So what is f dash of x for x power n? It's nothing but nx power n minus 1. Okay. So how did we derive from here to here? I'm not going into the derivation. This is derived by using first principles. When we learn limits and continuity, we used to learn the derivation also of all these formulas. But now, like I told you in the previous video, we do not have the derivation because we are not doing limits and continuity anymore. So I'm directly going on into the formula. Okay. So this is an algebraic function. Why do I call this an algebraic function? Because it's a variable x with a power constant. So nx power n minus 1. Okay. So now the second function. Now let us derive function a power x. A power x is nothing but a power x log a to the base e. Okay. Let's derive the next function. Again, this log a base e is a constant because this number a is a constant and x is a variable, like you know. So this is something like, let's say 2 power x. If you're differentiating 2 power x, what is the answer? 2 power x log 2 base e. Okay, so now let us derive log x base e. So this is nothing but 1 upon x. Okay. So next let us derive something like root x. So this root x is nothing but x power half. We've learned all this in the indices chapter. That's why I'm not going into the details of this. So x power half. So what do we get? 1 by 2 root x. Okay. So next, the fifth one. Yeah. Okay. Next, differentiation of a constant. It could be any constant like the number 5, like the number 928 or anything for that matter. Okay, when we differentiate any constant, we get the value 0. Okay, there is no x in this. So this is the table that is very, very important for us to know. Okay. Now, based on this table, let us do a few problems now. Okay. Let's keep this table as the base. I hope all of you have copied this down. Now, keeping this table as the base, let us solve a few problems. These are the 5 basic rules that you need to remember. Root x is 1 by 2 root x power n is nx power n minus 1, a power x is a power x log a base e, log x base e is nothing but 1 by x, and differentiation of the constant c is nothing but 0. Now, let us go to some basic problems, okay? I'm going to pick up these basic problems from your textbook, from some solved examples in your textbook. The first one. So come to your textbook. So this is page number 6 on your textbook. Okay, this may not be the correct page number. Where does this come? Page number 8.6 on your textbook. So come to the first question, A. 3x square plus 5x minus 2. So let's solve that. 3x square plus 5x minus 2. This is the first question. So this constant, we're going to write the 3 as it is. Don't do anything to the constant. Come to this number x square. How are we going to differentiate x square? So put an into, and after that x square will be nothing but, using the above formula, x power n is, bring the n to the side, into x power n minus 1. Okay, so if I'm differentiating x square, what would I get? Put the 2 here, then write your x, 2 minus 1. So it's nothing but 2x power 1, or rather 2x. So the differential of x square is nothing but 2x. Okay, similarly, if I'm differentiating x power 5, it will be 5 into x power 5 minus 1, which is 4. Easy enough? Okay. So now let us come to 3x square. Write the constant 3 as it is. Do not worry about it. X square will be nothing but 2 into x power 2 minus 1 is 1. So write it as it is. Plus. Now let us write the constant 5 as it is. It is called as a coefficient. Coefficient is the constant accompanying a variable. So write the 5 as it is. Now 5 into differentiation of x. X has the x has the power 1. So when we write here, it will be into 1. Okay, into x power 1 minus 1. 1 minus 1 is 0. So x power 0 is nothing but 1, right? So that's how we get this part. So here what we would be having is 5 only, because 1 into x power 0 has become 1. So 1 into 1 is only 1. So what you have is 5 here. Now all of us know that the differentiation of the constant is 0. So what we are left with is 3 into 2, 6x plus 5 is the answer for this. Okay. Let's move on to the next problem. Okay. So I am going to take this problem, that is part B, a power x plus x power a plus a power a. A power x plus x power a plus a power a. Okay. Now there are 3 terms here. Now please remember, when we are adding 3 terms, it is like solving 3 separate questions. So differentiate each term. Differentiate each term as though they are 3 separate questions. Now first is a power x. A power x, we have written the answer as a power x into log a base e. Now let us just apply that. So a power x is nothing but a power x log a. Okay, then put the plus as it is. Come to x power a. Like I told you, x is a variable, a is a constant. So these are all commonly accepted acronyms, or commonly used. A, B, C, K, M, N, these are all normally constants. X, Y, Z, these are normally variables. So normally they don't use any letters apart from this. So you can safely assume that A is a constant, X is a variable. So how do you differentiate this? A into X power A minus 1. That is all. Plus, now come to A power A. Since I told you A is a constant, this is also a constant. Power A is also constant, making this whole term a constant. So when the whole term is constant, differentiation of the entire term becomes 0. Okay. So now the final answer is only these two terms. So A power X log A base E plus Ax power A minus 1. That's all. Now let us go to the third sum. So what we have here, the third question is this. So we have 1 by 3. One by 3 x cube minus 5x square plus 6x minus 2 log x plus 3. Let's just check once. Yeah. So now let us solve the problem. Okay. So go term by term. 1, 2, 3, 4, 5 terms. So it's like 5 separate questions. Okay. Let's start with the first term 1 by 3. 1 by 3 x cube. So write the coefficient 1 by 3 as it is, multiplied by x cube will be nothing but 3 multiplied by x power 3 minus 1 is 2. Okay, write this as it is. Come to the second term. Now the second term has a minus. Write it as it is. Now minus 5, coefficient to be kept as it is, put an into. You have the term x square. Okay, so the power is 2, write it as it is, into x power 2 minus 1 is 1. So leave it. Next, put a plus, coefficient 6 to be written as it is. The differentiation of x is 1, we just saw. So we are not going to write anything else here. It is going to be only 6. Then next we are going to write minus 2. The coefficient 2 is to be written as it is. Log x differentiation is 1 by x. Now the last term, the fifth term is 3, constant, which is a 0. So we can just put a plus 0 and leave it there. Okay. Now let us simplify this whole term. It is nothing but 3 and 3 will get cancelled. So we are left with x square minus 5 2s are 10x plus 6 minus 2 by x. Now I'm going to leave it as it is without further simplification. Now you can look at the options and suppose further simplification is required, then we can take the LCM here. So let's move on to the next question. Question number 4. Okay. So now look at these questions. The first 3 questions that we saw here was 3x square plus minus plus minus and so on. It was only addition and subtraction. From the 4th question onwards, it's product of 2 terms. E power x multiplied by log x. 2 power x multiplied by x power 5. The next question is x square divided by e power x. The next question is e power x divided by log x. Here it is again multiplication, here it is division. So you see D, E, F, G, H and I. All the 6 questions have a multiplication or a division. So we will be solving this by doing the product rule or the quotient rule, which we will be seeing in the next video. So in this video, we will stop with this. So what we have learned in this video is basically the basics of differentiation. So we learned this table. In this table, we have learned 5 formulas only. You do not need to know any more formulas. Like I told you, it is very diluted or simplified at the CA foundation level. All you have is only these 5 formulas. You don't have trigonometric differentiation or any higher level differentiation. So all you need to know is these 5, and for that you will be using that in these cases. So we look at the division rule or the quotient rule and the product rule in the next video. Thank you.